Hey folks, so I'm afraid I'm going to have to half-ass this one. Things have not been going well for me in terms of trying to get a video out, so I'm a bit late, I'm sorry. I spent a heap of time researching something specific that I wanted to bring, and about 3 days before I was going to do the video, it broke. And I wasn't able to bring you the device, and I'm not going to tell you what it is because I'm hoping I can get it fixed. But I've been arguing with that, and then I decided to switch back to the Z80, and I've had some success, but I'm not quite there yet. So I thought I'd give you sort of like a midway project update to tell you what I've been doing. So the Z80, I haven't touched in, gee whiz, like 2 years, and I got the bug a couple of months ago, and so I'd started fiddling with it again. And I stopped last time because I was having trouble interfacing the static RAM, which is this one here. I suppose that's the point I should probably run past again for those who are either new to joining or have forgotten. We have an Arduino here, which I'm using for a timing source, which I still feel horrible and dirty about, but it's an easy way to ramp up and down the speed without having to build a bit of logic to do it. I have the Z80 here. I've got some flash RAM here, which I'm using for a ROM. I have a static RAM here. I have a 7400 series NAND, which I'm using for memory decoding. And I have a 16C550 UART here with its crystal. And up here's a Max 232, which kicks the TTL voltage levels up to the RS232 levels. So, I was having trouble adding the static RAM. I was getting a heap of gibberish off my A to Z output program. And then, while I was trying to diagnose that, all of a sudden I stopped getting any output from it at all. And every single thing that I did to test said that it was working. I was seeing the line voltage twiddle. I mean, I couldn't figure it out. That was, yeah, like I say, about 2 years ago. And about 4 or 5 months ago, I had an epiphany. I was in the shower, and I was washing, I imagine, and suddenly I went, oh, duh. And after the shower, I came out, I'm assuming I got dressed in between, and fixed it. And what I was missing was my ground line. I have a receive and a transmit, and I swear to you, I don't know how this worked, because I went back in past videos, and I didn't have a ground line, so I don't know how the hell this thing worked in the first place. But without a ground reference, this thing should never have worked at all. I should never have seen any serial out of it. So I don't quite understand that, but I added my ground reference, and all of a sudden, I got output. By the way, I have a cold, so if I sound snottery, that's why. So then I went back and I went, okay, how did I screw up the static RAM? And I was seeing complete gibberish. And I went and I looked at my wiring. And this is the 7400 series NAND. We have ground on pin 7. We have plus 5 volts on pin 14. And then we have our 4 NAND gates here. And it's an input and input and output, input, input, output, input, input, output, input, input, output. And what my memory decoding chip, if we'll ignore my phone, does is it says if we're looking at the memory and the most significant bit, or address line 15, is high, we are looking at the upper half of RAM, everything above 32K, which is where I want my RAM chip to be. I want my ROM to be the lower 32K, and I want my RAM chip to be the upper 32K. And so this gates and decides which of the ROM and the RAM is enabled at any given point in time. What I had done was I had gotten these 6 lines here backwards. See, it's output, output, I'm sorry, in, out, and I had it in, out, in, out. And so that would have caused, when I had an out and an in connected, it would have caused floating lines on the input of either of these chips, and all sorts of other crazy stuff which would not have played well. So as soon as I spotted how I'd screwed that up and I rewired it, everything worked as it was supposed to. And so the next thing was to figure out if I was actually using the RAM. And so what I decided was I was going to test by reading from the UART into memory and then outputting. I'd never actually read from the UART. So, you know, like a programmer, which is what I am, I started from what I knew and I worked up in small incremental steps. So I wrote a program or I modified the existing output program to read a character, echo it back, read a character, echo it back. And that didn't work. I had it print a banner. It was supposed to say ready, so I knew that it was active, and then it would start echoing the characters back. And it would print the first R of ready, and it would print it again, and again, and again, infinitely. So obviously there was a loop somewhere. And I eventually realized, after hooking up my logic analyzer, which is the snake, that what was going on was I was using a call and a return in my assembler. And the call and the return is a subroutine function. You have a line of code, you call from that line to your subroutine, and then you return back to the line after your call. And the way that it does this is it takes the next address, the next program counter address, the next chunk in memory it's going to read for the next instruction, and it pushes it onto the stack. And the stack is a last in, first out array of bytes in memory, and it grows down from wherever you assert the stack to be. And I didn't think of this when I built it, because what it means is that I have to have working RAM to be able to write the return address to the RAM, which would work if I had my RAM right and if I had told it where it should start the stack. In the Z80 it appears to be undefined, so I'm not quite sure what it defaults to. In the 6502 it defaults to like 0 by 100, but in the Z80 I'm not sure what it is. I couldn't find it documented. So it could have been setting it in ROM space, so it could have been reading its return address from the program code that I had written. I have no idea. So I eventually figured out what the hell it was doing, and it was going to the loop to print out the letter, and then it was jumping back to completely the wrong place, which just happened to be a return to the loop that was supposed to output the letter. And so it was setting the letter in the register, R, it was outputting, jumping back to the wrong place, jumping back, outputting again, jumping back to the same wrong place, output back, and just looping infinitely. So I rewrote the code I added a line to initialize the stack pointer, and now I get an R and a whole bunch of spaces. So obviously I've still got something wrong. So I went back to my logic analyzer, and the problem is that this is such a dog's breakfast mess that trying to get these lines hooked up to the correct address and data lines is a pain in the arse. Now the address lines, I could go with like the lower 6 or 7 lines, because all of the code is in the first, I don't know. This is the code here. Now it's commented, but the last address is 0062. So it doesn't go very far. It's only, 60-some bytes. But it jumps high to do the pop and the pull from the RAM, so it'd be really helpful to have those high-end bytes as well. I'm sorry, the high-end address lines. And I am getting so many unpredictable results where, I know what the byte that I'm supposed to see is, and it's not what I think it's going to be. And so there's obviously lines that aren't properly connected, and so I'm not getting an honest result. So I think that I've come to the point where I have to fix my debugging. So I'm going to go from this to probably some Vero board. Something like this, where I will have a board for the Z80, a board for the RAM and the decoder, a board for the UART and the Max 232, and I'm going to have a very simple bus. This is supposed to be cut in half, and this was going to be my bus connector. I think what I'm going to do is I have a bunch of these right angle connectors. I think I'm going to use a SCSI cable as my bus back plane, Either that or I'll build a back plane, but then I have to buy a bunch of connectors that match this anyway. This is my theory for now, but what it does mean is that I have a whole lot of soldering to get to connect all of these lines together. So I think that's what has to come next, is I have to fix this so it's not a complete pig of a job to debug it when I screw things up. What my plan is to, aside from make the bloody thing work so I can talk and I can test the static RAM, is I'd like to add a second UART. Testing with this is a pain in the arse because every time I rewrite the program I have to pull the static RAM off. I have to pull the flash RAM off. And the flash RAM is in the mix of this cobweb of nest of wiring here. So I invariably end up pulling some of them out because I've got the bus coming from the processor to the flash and then the flash to the static RAM. And it's just a real pain in the neck by now. So it would be really nice, even when it goes onto this board, if I don't have to keep pulling this flash RAM off to reprogram it. So I'd like to add a second UART, and I'm going to write a very simple bootloader into the flash. And so the initial program will come up in ROM, and it's going to use the second serial chip to load into memory its boot code. So it will chain off the flash RAM, it'll pull bytes from the serial line which is going to be connected to a server on a PC, which will hand off whatever the incarnation of the code that I've worked on so far, and then it'll jump to that and execute and start running. So this way, instead of having to rewrite the flash, I simply have a program on a PC that I assemble, and then I boot this, it'll pull the program. If I've screwed it up, I can debug it, fix it on the PC, hit the reset, and it'll just pull a new copy and start up again. That way I'm not constantly fiddling with this crap. That's the plan anyhow. Obviously my plans are going awry lately. So ahead of me I have a whole bunch of soldering and remounting these and seeing if I can make it work, because it would be really depressing if I pull this whole thing apart and nothing works right. But I'm not sure I have any other choice. This was useful, but it's a mess. And a lot of people have commented that when their breadboards outgrow, they start getting all sorts of really hinky crap going on, and I think I've gotten to that point. So I'm going to try and tidy this up. Hopefully I'll get back to that shortly. And I'm going to really try and get the last project fixed so I can bring that to you, because it requires being outside where there is daylight, which means it has to be done before it gets crappy and autumny and wintry. And that's rolling on pretty fast in Iowa here. Anyways, if you've been watching, thank you very much. I apologize again for the delay. I really appreciate all of your comments. I really, really do. Thank you so much. Have a wonderful day.